Okay, we're going to review how do we solve absolute value inequalities. Okay, so an inequality means it's not equal to. Okay, so it's greater than or less than. And remember, absolute value is the distance from 0. Okay, so what if I have absolute value is less than or less than equal to a certain value? What does that mean? Okay, well, if we have less than, think of less than as an and problem, okay? If we think about graphically, if the distance from 0 is less than a certain value, that means that it's going to be closer to 0. So I could be going a units to the right. I could be going a units to the left. But if it's less than, that means that I'm going to be shading, including all the values in between. So less than is an in between. I have many possible options. I don't just have one number option. If it's less than, we're going to have open dots because it can't hit exactly that a value. If it's less than or equal to, well, that means the only difference is that it can exactly hit a units, and so we have a closed dot. So what does this mean number-wise? This means that a certain number is less than a positive a on the right-hand side, or I could be going greater than a negative a. If I'm talking about left, again, with absolute value, negative just means it's left of 0. And a reminder that we have an open dot. We have an open dot if it is less than or greater than, closed dot if we have equal to, okay? So it's an open dot if we have less than, greater than, closed dot if we have less than, equal to, greater than, equal to. Okay, so that is less than. Now what if we have absolute value, distance from 0, is greater or greater than equal to a certain value? Well, if distance from 0 is greater, let's think about what that's going to look like on a number line. Well, if it's greater than a certain value, well, I'm not going to be shading the part closest to 0. I'm going to be shading the exterior part, the outside part. So distance from 0 is greater than a certain value. I'm going to be shading the furthest away from 0. Again, since absolute value is just distance and we don't know if we're going right or left, it could also be in the exterior left part of the graph. And if we have greater than or equal to, the only difference is we have a closed dot instead of an open dot. So if we have greater or equal to, we have what we call an or problem. Okay, or means it cannot occur at the same time. That means that we're shading the outside part. And how do we write it as an inequality? This would be that x is less than a negative a, or x is greater than positive a. It cannot occur at the same time. Now notice with less than, and is the in-between part, because it can occur. A number can be greater than negative a and less than a at the same time. Okay, so with absolute value inequalities, think less than, we're shading the in-between. Great or, we're shading the exterior. So let's do some examples of these. So how do we solve absolute value 2x minus 1 is less than 5? So your first step is always to isolate, okay, the radical. Isolate the absolute value. Well, this is already isolated, check. Okay, I already have absolute value on one side all by itself, so that part's already done. So next, we need to look at our sign, and we need to say, do we have a less than or greater? And if we look here, this is a less than, so it's an and equation. So when we have an and equation, that means that I'm shading the middle part, something is greater than one part, less than another part. So we can write what's called a compound inequality. Everything inside the absolute value, distance from 0, could be less than a positive 5, or it could be greater than a negative 5. So and problems, we can write a compound inequality. Everything inside the absolute value, less than positive 5, or greater than negative 5. And now we're just going to isolate the x, solve for x. So if we solve for x here, we have plus 1 that I need to move to both sides. And since we have a compound inequality, I'm just going to do it all at the same time. So I can add 1 to the right, I can add 1 to the left. So we have 2x is less than 5 plus 1 is 6. Negative 5 plus 1 is negative 4. And lastly, to isolate the x, we have 2 times x. So 2 times x inverse operation would be to divide by 2. So x is less than 6 divided by 2 is 3. And negative 4 divided by 2 is negative 2. Okay, so what values of x will make this absolute value 2x minus 1 have a value less than 5? All of the x values, so if we think about a number line, all the x values between negative 2 and 3. Now notice we have less than, we have an open dot because it's not equal to. And since it's an and problem, we are shading the in-between part. Okay, so all of those values, integers, and including all the itty-bitty decimals in between, negative 2 and 3. And how can we be sure? We can always check. So how do we check? We check by plugging into the original problem. Okay, so my original problem was 2x. Well, let's pick an x that's shaded. The easiest number to plug in would be 0. Let's plug in 0. Because 0 is shaded, so it should make a true statement. So let's see. So 2 times 0 is 0, minus 1 is negative 1. Absolute value of negative 1 is 1. Is 1 less than 5? Yes, it checks. I know that my answer is correct. So all the values between negative 2 and 3. So because we are solving absolute value inequalities, we're going to have more than one possible number option. And actually, there's an infinite number because I have a ton of itty-bitty decimals in between all of those two numbers. Another one. What if we're going to solve absolute value 2x plus 4 greater than or equal to 6? So again, first step is to isolate the absolute value. And here it's already isolated, so check. I don't need to do anything additional on this one. So next I need to look and see, is it a greater or a less than? Well, here, again, big part opens to the larger part, so this is a greater problem. Greater. Well, when we have an or problem, they can't occur at the same time, okay? So because they can't occur at the same time, I can't write a compound inequality. So I need to write two separate statements. I need to say everything inside the absolute value, distance from 0, yes, could equal greater than or equal to 6, because again, we're looking at the outside parts for or, right? Or means we have the exteriors. Or everything inside 2x plus 4. We have to flip the sign, would be less than equal to, and we have to use negative 6. Because again, we want the exterior part, so we have to be going left of the negative part, okay? So with or problems, you have an extra step, okay? To get that second inequality, you have to actually flip your sign, and you have to add a negative. Okay, so let's go ahead and find these x values. So next we're just going to solve for x. Solve for x. Okay, so to solve for x, here we need to subtract 4 from both sides. Again, inverse operations. So 2x is greater than or equal to 6 minus 4 is 2. Or 2x less than or equal to negative 6 minus 4 is negative 10. And 2 times x, inverse operation is to divide by 2. So x is greater than or equal to 2 divided by 2 is 1. Or negative 10 divided by 2 is a negative 5. So if we think about what this represents on a number line, let's draw a number line out. We have positive 1, and we have 1, 2, 3, 4, 5, negative 5. Again, it's equal to, so we're going to have closed dots at 1. And notice x is greater than. It's an or problem. We should be going to the right, or think of this as an arrow. It's just shading to the right. At negative 5, again, closed dot. And if it's an or problem, we should be going left. And notice the arrow points. X is less than. It kind of looks like an arrow. We're shading left. And to check, again, just to make sure that we're correct, I always plug in an easy point, okay? Always the easiest point normally to plug in is like a 0 or a 1. If 1 is shaded, if 0 is, like here, 0 is not shaded, so we could plug in to make sure that it makes a false statement. Or if it is shaded, you can plug it in to make sure that it makes a true statement. But I like to plug in 0 is the easiest number to plug in. So let's plug in 0 to check, and we want it to make a false statement. So we're going to plug in 0. 2 times 0 is 0 plus 4 is 4. Absolute value of 4 is 4. Is 4 greater than or equal to 6? No, it is not. False, which means we should not have it shaded, and we don't have it shaded, okay? So that is a true statement there. So because it's false, we should have no shading, and that checks. No shade, and yes. Oops. Yes, we have no shading. So I know my answer is correct. So what x values will satisfy distance from 0? Absolute value 2x plus 4 is greater than or equal to 6. All of these values here. Any number that is greater than or equal to 1, or that x is less than or equal to negative 4, or negative 5. So let's try one more. So let's solve for absolute value. 2w plus 3 minus 7 is less than or equal to 9. For absolute value, 2w plus 3 minus 7 less than or equal to 9. So first step is to isolate the absolute value. And here we have to do some work because that absolute value is not on one side all by itself, okay? So let's isolate the absolute value. That means that we are going to need to move. I would always start with what's the furthest away from the absolute value, which is the minus 7. So inverse operation from a negative 7 is a positive 7. So add 7 to both sides. 9 plus 7 is 16. Next, this is 4 times. Never, ever, ever distribute a number outside the absolute value inside. It is not, absolute value is not a parenthesis. It is a barrier, okay? So this is 4 times. Inverse operation would be to divide by 4 on both sides. So absolute value 2w plus 3 would be less than or equal to 4. So now the absolute value is isolated, we need to look at our inequality. So do we have a greater or a less than? Well, this is a less than equation. It's an and equation, right? So what can we do with and? And means distance from 0 is between two values. Between two values. Okay, so it is between a positive 4 and a negative 4. Okay, remember you need one side positive, one side negative. Think of a number line. So now we're just going to solve for w. So if we isolate our w, we need to utilize inverse operations. So inverse of adding 3 is subtracting 3. So let's do that on both sides. 4 minus 3 is a positive 1. Negative 4 minus 3 is a negative 7. Lastly, we have 2 times w, so inverse of multiplying is dividing. 1 divided by 2, let's just keep it a fraction. Fractions are your friends, 1/2. And negative 7/2, again, fractions are your friends. Just keep it a fraction. And how can we represent all the solutions on a number line? Draw a number line. Negative 7/2 is negative 3.5. So in between negative 3 and 4, right? And we have a closed dot because it is equal to. So we have a half right here at closed dot. We have negative 3.5 closed dot. And it is an and problem, right? So we shade in between. That's actually why we can utilize the compound inequality. Okay, we have two inequalities combined only with and problems. So again, you'll have, what, a half here, and you'll have negative 7/2 here. And just to be sure that our graph is correct, check your answer. Always go back to the very original problem, because otherwise, if you made any calculation errors, you won't get the right answer if you're plugging it in to an incorrect step. So always go back to the original. And always pick the easiest number. Easiest number is typically either a 0 or 1. So if 0 is shaded, we want to find a true statement when checking. If 0 is not shaded, we want to find a false statement. And again, you could also, when you're checking, plug these into calculator. Again, I've told you Desmos is a calculator that you could utilize online. So let's plug in the easiest number, which is 0. 0 is shaded, so we want to find a true statement here. So for absolute value, 2 times we're going to plug in 0. Now all of this needs to be less than equal to 9. So to simplify, 2 times 0 is 0. 0 plus 3 is 3. So absolute value of 3 is just 3. 4 times 3 is 12. 12 minus 7 is 5. So what do we find? Is 5 less than 9? Yes, that is a true statement, and it is shaded, which means that I can box my answer. All the values between negative 7/2 and 1/2 will satisfy this inequality. Okay, so to solve inequalities, think isolate absolute value, solve for the variable, and make sure, in order to figure out how to set up your two statements, is it a less than, create a compound inequality in between two values, positive, negative, or is it a greater? Write the inequality, flip the sign, make it negative.